Hi, this is Mr. Gieske. There are two proofs on points, lines, and triangles, worksheets, points, lines, and triangles that give students a lot of trouble. And they're critical to understanding how the centroid of a triangle is, or has certain coordinates. So we need to prove a few statements here. First one is that we want to show that AK is parallel to LB. Okay. So we want to prove not that they're congruent, sorry, they're parallel. Okay, I guess one way of doing it is to show that quadrilateral AKBL is a parallelogram. Okay, if we can show that, then we know that those two sides are parallel. Okay, so how do we know, how could we prove this is a parallelogram? One way of showing that you have a parallelogram is to prove that diagonals bisect each other. So if we can show that diagonal KL and diagonal AB bisect each other, meaning that this is congruent to this and this is congruent to this, then we'll have AKBL is a parallelogram and that AK is parallel to BL. So let's prove that diagonals KL and AB bisect each other. Okay, so this is sort of like working backwards from a proof. I'm sort of making the statement equivalent and maybe in a more approachable way. Okay, well, how do I know that these two diagonals bisect each other? Well, independent of the fact that this of quadrilateral AKBL, I've got this big triangle ACB. Okay, earlier in the problem, in the description, you were told that CM is a median of triangle ABC. So therefore, we know that CM intersects AB at its midpoint. So this is certainly congruent to this. AM is congruent to AB, MB. To MB, because CM is a median of triangle ABC. Now this is median, this is a geometry median, not a statistical median, but keep those separate. Okay, and then the second bit is that we knew that KM is congruent to ML because earlier in the worksheet, L was determined to be the point equidistant from M as K was. So you extend the median CM all the way to L until this segment ML is the same distance, same length as MK. So MK is congruent to ML by definition. That was the way that L was defined. Okay, so therefore we have these two segments congruent, these two segments congruent, which means that, oh, these diagonals of the quadrilateral bisect each other. So these diagonals bisect each other, which makes AKBL a parallelogram, which means that finally AK is parallel to LB. And we're done with that part. Okay, so that's 6A. 6B is a little trickier. We're trying to show that KC, this length right here, is twice the length of KM. Okay, so how do we do that? Students inevitably point out that in the blue triangles here, we've got CBL and CKN. Sorry, that would be CNK, are similar. How do we know that? Well, because of the last proof, we know that AK is parallel to LB. And if AN or KN is an extension of AK, then we know that if you draw, you take this triangle CBL and you draw a parallel side to it here, then you're going to create similar triangles. That's just a theorem from geometry. Okay, so if they're similar, there must be a ratio of proportionality. So how do I know a ratio of similarity? How do I know what that ratio is? Well, you can see that if CM is a median and AN, or sorry, AN is also a median, then K must be the centroid. Okay, and this side must be bisected by this median here. So we know that this side is the same length as this side, or that segment CN is congruent to BN because AN is a median. Okay, so therefore this triangle CNK, and this is a blunt way of doing this, over triangle CBL must equal 1 to 2. You can see that this side is 1/2 of that side. So therefore, the ratio of proportionality between these two triangles is 1 to 2. Okay, so therefore, we can apply that same reasoning to this side and say that CK is 1/2 of CL. So CK to CL, I guess I shouldn't put the, is 1/2. Okay, and from the previous proof, we knew that this side was congruent to this side. Okay, so therefore, this side length right here, so we know that LK and CK are the same length, and that MK is half of LK, which makes MK half of CK. Okay, so we know that, let me just make one more statement here. We know that LK is congruent to CK. So therefore, I can say that MK over CK is 1 to 2. And that's essentially the proof here. Therefore, that's what that says. KC is equal to 2KM. Okay, so this isn't a very difficult proof. We've just got to work on the fact that we've got similar triangles and the ratio is 2 to 1. And once you pull back the fact that these two segments are congruent, then you obviously know that half of this one has to also be half of that one. And that's essentially the proof. Okay? Okay, the upshot of these two proofs is that we've learned something about point K. Let's just remind ourselves what it is. So point K is the intersection of medians AN and CM. Okay, which makes it a centroid, or the centroid. Okay, the centroid is an intersection of the medians of a triangle. So of triangle ABC. Okay, so point K, I'm just going to mark it, is now called the centroid. Okay, Now, what's interesting about the centroid is that we've just shown that if you start at point M and you're on your way to point C along that median, okay, so you're traveling along this median, we've just shown that this length is half the length of this one, so MK is half of CK, which means that along the median, point K is 1/3 of the way. So we've shown that there are, that's really not handsome. That's 1, and then that's 2, if you count units. So we'll just say that centroid K is 1/3 of the way along median CM. Okay, and I could have said the exact same thing about along median AN. In fact, so point centroid K is 1/3 of the way along any median. Okay, it doesn't matter how I arrange this proof. Everything's been abstract. It doesn't matter that I use one side instead of another. I could make an identical argument over here for median AN, and had we drawn the one over here, B some point over here, I could have made an identical argument on that side. All the geometry would be the same. So what we're learning here, and this is an important part for the final bit of the worksheet, is that point K is an intersection of medians, is a centroid, and that point lies 1/3 along the way from, or along a median, any median at all.